Hi everybody, I am Daniele, a PhD student of the 37 cycle, and in this video I will guide you through my research activity. In 1911, playing with mercury, Ons measured that its electrical resistivity cancels out at a very low temperature of 4.2 Kelvin. He had discovered the superconductivity. It was later discovered that the phenomenon is common to many other materials. At a very low temperature, superconductors can carry very high currents without offering any resistance. And today they are used in numerous fields, from particle physics to medicine via engineering, where they find wide application in nuclear fusion and power transport. The very high current that can be carried by a superconductor is a function of temperature and magnetic field. Given the latter, the resistance of the superconductor is zero, so that it carries the whole current only up to a certain temperature. Beyond this threshold, the current is shared with the other conducting materials that may be in contact, called stabilizers. Now, since the overall resistance is no longer zero, the material begins to heat up. This heating promotes temperature rise, and once the critical current is exceeded, the superconductor shows a huge resistance, and it does not carry any current. The cable burns out because the current that should flow through the stabilizers is too high for them. This extremely destructive phenomenon is called quench and must be studied and predicted to avoid accidents, as you see in this picture. The superconducting state is extremely fragile, and in the typical operating condition of the application, it is constantly under attack, as you may see from this picture. Hence the need to study cable behavior not only under nominal operating conditions, but also under conditions where quenching might occur. The goal of my research activity is to develop an open source and open access computational tool to simulate the behavior of superconducting cables, the OpenSC2. It is developed following a structured approach in a modern and versatile programming languages, and it is flexible enough to allow different cable concepts and operating conditions to be simulated. So let me give you 3 takeaway messages for today. First, superconductivity occurs in some materials at very low temperature, and it is already exploited in our everyday life. Second, quench consists of the loss of the superconducting state of the material and can destroy the cable. Third, OpenSC2 is an open source modeling tool that can contribute to the study and design of superconducting cables. Thank you so much for listening and paying attention.